Today we will be going over our fourth type of transformation, and that is the dilation. So let me get back to the beginning here, that would be helpful. Day one is understanding just the concept of dilation. If you look at these three pictures, those are dilations of one another. If you use this idea of dilation, a dilation is simply either making an item smaller or making this item, the original, larger. So a dilation is either an enlargement or a reduction of an image. So if we look at this first example, we have a square, and that's the original, and this is going to be our image, is the blue one. So the original was the outside one. So if I look there, if we're trying to understand it, the first thing you have to find is the center of dilation. This is the point of which the figure is dilated. So if I look here, this point stayed the same. This is the center of dilation. It got bigger or smaller, in this case, from that point right there. So I'm going to just call that C for center. Once you do that, in order to find the scale factor of a dilation, you have to mark two of the corresponding parts in both the image and the original. So if I pick this corner of the original as A, I have to pick the corresponding part of that in the image, so that would be this corner here, and that would be called A primed. Our third step then to find the scale factor is actually to set up the ratio. We go from the distance from the center of the dilation to the image point, and the distance from the center of the dilation to the original point. So I need to get a ruler, and I'll try to be as accurate as possible here. I'm going to put 0 on the point C, and there's my ruler. The distance from the center to the image, remember that's A prime, is 15. Over the distance from the center of the dilation to the original point is 30. If I reduce that, that gives me a scale factor of 1/2. So if I think about this, my original was larger than my image, so it's getting smaller. So my scale factor is 1/2, which is smaller than 1. The questions that it asks here is there an invariant point under this transformation? Yes, there is an invariant point. Remember, an invariant point is the one that remains unchanged or unmoved. The point under this transformation that's invariant is this point C. What do you notice about point C? Point C is not only the invariant point, it is also the center of dilation. So our center of dilation is going to be an invariant point. Okay, our next example here then is with triangles, and it actually wants us to determine which ones are dilations of one another. So it says Mrs. Tonelli cuts 3 triangles from colored paper and pastes them on a board. Which triangles are dilations of one another? They want to know triangle ABE, ACD, and GFH. Well, in order to be a dilation, remember you have to have a center of dilation. This triangle FGH does not share a center of dilation with either of the other ones because it doesn't have an invariant point. So that is not a possibility to be a dilation. If I notice though, the other two share the point A. So they both have the invariant point A, so it could be a dilation. So in order to figure this out, we have to compare their side lengths in order to see if the scale factor is constant. So I need to find all the side lengths. So on triangle ABE, this side is 3. This side is 2, and using our information from last chapter, a squared plus b squared, 3 squared plus 2 squared, gives us the square root of 13. No, 10. No, I'm right. 9, 13. I'm correct. The square root of 13. 3 squared is 9 plus 2 squared is 4, which is 13. So there's my 3 lengths for the red triangle. Now I figure, so if I write that over here, I have 3, 2, and the square root of 13. Now I figure out the side lengths of my second triangle. Across the top is 3, 4, 5, 6. 1, 2, 3, 4 down. 6 squared plus 4 squared is the square root of 52. So my three lengths here are 6, 4, and square root of 52. Now to compare those, you set up the scale factor. So if I look here, the 3 went over the 6, 2 goes over 4, and the square root of 13 goes over the square root of 52. All of those reduce to the scale factor of 1/2. So since they all reduce to 1/2, that means this is a dilation because the point of the center of dilation is A with a scale factor of 1/2. So what is the center of dilation? The center of dilation is A. Is there an invariant point? Yes, point A. Remember, the center of dilation will always be an invariant point because it's unchanging. So if I sum this up, we were asking which triangles are a dilation of one another. Triangle ABE is a dilation of triangle ACD. Okay, our next example, we're back to the squares, and it says it wants us to find the scale factor. Just like this last time, when we find the scale factor, we have to find the side length of the original, the side length of the image, and then we have to find the scale factor from there. Okay, so, and it doesn't matter which side you find, because if I notice this is a square, and we found out the last example that all of the sides would have to have the same scale factor. So just pick two corresponding sides. So I'm going to do the top of each figure. So that's 1, 2, 3, 4, 5, 6, 7, 8 across. And this is the original is 1, 2, 3, 4. I know this is the original because it just has A. A primed would be the image. So the side length of the original is 4. The side length of the image is 8. The scale factor, you have to be careful how you set it up. The scale factor is the image over the original. The image is 8 over 4, which reduces to a scale factor of 2. Okay, let's make sure this makes sense. Our original was smaller, so this is an enlargement. That means this number should be greater than 1. So since this is greater than 1, it makes sense that is an enlargement. That's how you can check to make sure you set up your scale factor correctly. Okay, the question says, if you know the length of the sides of the picture frame is 16 inches, how can you find the side length of the picture? So the picture frame is the outside. It is saying that in our new example it is 16. Using our information that we got that the scale factor is 2, how could you figure out the side length? Well, this was our scale factor of 2, meaning this enlargement is 2 times larger. Well, 16 divided by 2 is 8. So the side length of the picture would be 8 if the picture frame is 16 with a scale factor of 2. Is this an enlargement or a reduction? It's an enlargement. And there's a couple different ways that you can explain it. You can say because the image is larger than the original, or you can say because the scale factor is greater than 1. What would a scale factor of a reduction look like? The scale factor would be less than 1. So enlargement, the scale factor is greater than 1. Okay, here's your joke of this lesson. What shape is usually waiting for you at Starbucks? Please put your answer on the guided practice problem. Okay, now we're gonna make up some pancakes. So Mrs. Marquise is making pancakes on a griddle. At first, the pancake batter forms a 4-inch circle. So this is 4 inches. It flows to become a bigger circle. The scale factor of the dilation is 1.5. Find the diameter of the pancake. We know that scale factor is equal to the image over the original. So I'm going to fill in the parts that I know. This time they gave me the scale factor as 1.5. I don't know the diameter of my image, but I know the original is 4. So this is the equation I would solve. So in order to solve this, I would take both sides times 4. And I would get that my image has a side length or a diameter of 6 inches. So that's just working backwards using the formula for scale factor. Our next one here says a rectangle has coordinates A is 5, 1. So A is 5, 1, and remember, make sure you label them as you go. B is at 3, 1. C is at 3, 4. D is at 5, 4. Find the length and the width of the original figure and the length of the width of the image when dilated with scale factors of 2 and scale factor of 1/2. So it's not asking me to draw any of the other ones. It's just asking me to find the side lengths. So the side lengths of A, B, C, D would be 2 by 3. So my image, when dilated by a scale factor of 2, since this is larger than 1, I know it's going to be an enlargement. All you do is take 2 times 2 is 4 by 3 times 2, which is 6. The next one asks, what would be the image when dilated with a scale factor of 1/2? 1/2 means it's going to be getting smaller, so it's a reduction. So 2 times 1/2 is 1. 3 times 1/2 is 1.5. The next section we'll actually learn how to draw the dilation and how that would look. Your guided practice for this section is page 87, 1A and B. And this is the picture that goes with it. So to understand what it's asking, you can go to page 87. Your assignment then is page 96, 1 through 3.